Right, so as we mentioned in the last slide that we can express sequences, sets and functions recursively. So let's first look at an example of a sequence which can be defined in a recursive way. So let's see a sequence a sub n. So this really means when we put the braces is the sequence itself, and this sequence is an exponential sequence where each term in the sequence is a power of 2. For example, for n equals 0, we have a sub 1, a sub 0 equals 1 because 2 raised to power 0 is 1. For n equals 1, we have a sub 1 equals 2 raised to the power 1, which is just 2, and so on. So it grows exponentially. It starts from 1, then it takes a value of 2, 4, 8, 16, and so on. So it's an exponential sequence. So this is the general, you can say, iterative definition of this sequence. The same sequence can also be defined recursively. Okay, so what do we mean by the recursion here is that we try to express the nth term of this sequence in terms of the previous one times some number. Okay, so let's see how we can do this. So we start from a base case when we define the first value of the sequence. So a sub 0 is equal to 1. Okay, and then we define the next term in the sequence by doubling the previous one. So this is the recursive definition of the sequence. We define the value of the sequence in terms of itself, or in terms of the previous version of itself. Okay, so every next value in the sequence is obtained by doubling the present value. That's the idea of the recursive definition. So by recursion we really mean is that this term here is defined in terms of a previous version of the term of the sequence.